Hello and welcome to our second set of notes for statistics. This time we're covering sections 2.2 and 2.3. So this will go with the second homework set. So in this set we're going to kind of talk about frequency distribution, some graphs, some kind of charts. Some of these graphs, and especially the distribution, we'll start off with the histogram, will be important. We'll see that throughout the rest of the semester. So we definitely want to make sure we're familiar with it with this first note. So the first chart, first graph we're going to talk about is called the histogram. You might think of this as a bar graph. It's actually somewhat different. A bar graph is for qualitative data. This is something for quantitative data, data that is numerical in nature. So they're related, but they're slightly different. This is called a histogram. It is probably the most important graph we'll deal with in statistics. It's very frequently used, so it's pretty important. So we want to make sure we cover it. So again, the histogram, it's a graph. It is made of bars, like the bar graph you might be thinking of. These are going to be an equal width, and they're always going to have some kind of numerical values going across the bottom, kind of something that we can count or measure for numerical data. And that's going to be our histogram. And so the height of the bars here, the height of the bars, are going to either show a frequency, which would be a count for the range, or they're going to show a relative frequency, which is a percentage. In this situation right here, this is showing a relative frequency, and relative frequencies are always going to be percentages. They might be written in decimal form, like these are written in decimal form. So like the 0.2 here would be 20%, 0.15 would be 15%, be 10%, 5%, of course, 0%. And that's what this is showing. So we can look over here, we can say that this 15 maybe is range between like 63 to 64 inches, and that range is going to be close to 15%. That's what this chart is showing us. So again, that's a histogram. The histograms, they're bars, they have equal width, because the width here shows you that all the ranges are the same size, and they are going to be adjacent, and again, the height is going to be the relative frequency, or sometimes the actual frequency, the actual count. So this chart specifically is showing the relative frequency for heights of 3,264 female students from a Midwestern college. The question down here asks what percentage of students are between 63 and 64. Well, I kind of gave away the answer on that one, because if we look at that range from 63 to 64, like I said, we can see that that kind of fits pretty close to that 15. So it's 0.15 or 15%. Be careful when you're answering questions in my stat lab. They usually indicate with a decimal or percentage, so just make sure you answer appropriately with that. About what percentage of students have a height less than 61 inches? So if I was looking for like less than 61, I'd be looking at this range down here. We'll look at range from 61 down. And so that means I'm going to be including these bars down here. So like bars like this one, and this one, this one. After that, they get pretty small, probably negligible. So I might say this one is pretty close to 0.05. That's kind of stretching it, but just to call it close. This one looks like it's a little bit less than half, so maybe let's call that 0.02, just to make a nice round number. We're kind of estimating right now, so we're not going to get exact values. Let's call this one 0.01, just to make life easy. We'll call them round numbers. So let's say that's like 0.05, 0.02, 0.01, 0.05, 0.02, and 0.01. So we just put those together, and we'd find out what percentages could be down here. And again, this is an estimate. We're not being exact because we can't. We don't know exactly what these are. We can get an idea. This looks like it might be about 0.08 or 8%. So that'd be just that combined value. So we're looking at that whole range from here over. Next question asks, how many students are less than 61 inches tall? Well, if we have a percent, we think it's about 8%. And we know there are 3,264 students total. Well, we just need to find 8% of that total amount. And that'll give us an idea about what percentage is going to be in this school is going to be less than 61 inches tall. So we'll take 8%, we'll use the decimal form for multiplication, so we'll just multiply 0.08 times that 3,264, and that'll give us the count we're looking for. So I'm just going to type in the calculator right quick. And so we get, I got about 261.12, which again, since we're looking at how many students, we probably round that to the nearest whole number. My math, I would probably expect that. They'll specify if they want a rounded value or not. on questions. You always want to look when you're putting your answers in the answer box. Look at the little fine print underneath that. A lot of times it's parentheses. It will say what kind of answer they accept. If they want a decimal or a fraction. Remember integers. If we use the word integer, it means a whole number, positive or negative whole number kind of thing. But yeah, so that's a histogram. We'll see a lot of these throughout this course. So the next thing we're going to do is we're going to actually make our own. So let's make our own histogram using the data we have right here. Now when you make a histogram, you got to do two things. You got to figure out what you're going to count by vertically and what you're going to count by horizontally. To do these, well, first off, you got to think about how high are you going to need to go. And so you can see here this chart has family sizes 1, 2, 3, 4, 5, 6, 9. And it has their frequencies. So you can see like the family size of size 1 is frequency 5, 2 is 17. So I know I'm going to have to count high enough here. I'm going to be able to include at least 17. And that's if I only have one row, one column per number here. But if I have to combine some of these, I'm going to have to go taller. So we'll actually look at the bottom and see how much room I have. Do I have room for 9 things? So if I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, I do. So I have room. I can count just by ones. And that lets me fit all these on this chart without having to group anything together. Sometimes you don't have to group stuff together when you make a histogram. Like the last one, I guess they went by ones again, but sometimes you'll see some stuff where we might count by 2s or 5s or something like that. Okay, so we got 0 through 9. Now we want to put in their frequencies. When you're doing frequencies like this, you got to kind of make a choice. Do I want to put group 1 before 1 or after 1? But decide which way you're going to do it and then just be consistent with the whole chart. So if I think I'll probably put group frequency 5 and group 1 after 1, then when I do 2, I want to make sure I put that after 2 and just be consistent with it. And so maybe I'm thinking the group of 0 is empty. If you did the same chart and just shifted everything to the left one, it's not really going to be a different chart. It's going to look the same if you started with this one being your 5 and that one's your 2. So just be consistent how you do it. So I think I'm going to think of this 1 going in this space. So it's going to go up to 5. Now I need to make this vertical fit 17. So I think, what do I count by? So this will be tall enough to hit 17. If I go 5, 10, 15, 20, that works. But I'm not using my top row. Maybe I can do better. What if I go by 4s? 4, 8, 12, 16, 20. And that's high enough, and I can use all the rows. So let's maybe go by 4s, just to get a little bit more usage out of this chart. 16 and 20. And that way, now when I go to do my 5, I know that the 5 and family size 1, it's going to be just over this line. It's more than 4. I fill that bar in. My first row, my row with 2 families, well, that's going to be 17. So I'm going to go up past 16, just past 16 because it's 17. And that's going to be that bar. Okay, and then the next one's 12, which actually is right there. It's right on the bar, so mark that off. Next one's 8, so we can go mark it there. That's going to be 8. Next one's 2, so that's going to be halfway to 4, right? So 2 is half of 4. We have 1, which is going to be half of that. So it's going to look like that. Next one's 0, so we leave it blank. Next one's 0, and then 9 has 1 again, so it's going to be the same height. Okay, so this would be a histogram. Following this, a lot of times when you make charts and graphs, it's good to have a label. So I'll just go put a label right there. It's family size. So it'd be the size of the family, and this would be, in this case, would be a frequency. It's not a relative frequency because it's not a percentage. It's an actual frequency. It's the count. So this is the number of that family size. So you get family size 1, there's 5 of them. Family size is 2, there's 17. And that would be a chart. This is a histogram. A histogram is a way to display data. So we look at this, so we get an idea of what the data visually looks like. And statisticians use this in real life. This is something a professional statistician will do, is they'll take a sample of data and they'll visually look at it, determine what it looks like, and that will help them make judgments about the data, understand things about the data. Some things they'll look at include the next two. One thing to look for is the data a normal distribution? This is a really important term. We're going to see this throughout the whole semester. Not every section, but it'll come up all throughout the semester. A normal distribution is really nice, easy to work with because we're trying to do interest statistics and we're not going to make things super hard. we're going to tend to want to work with normal distributions. A lot of our problems will involve normal distributions because they're a little bit easier to work with. The math is easier. So a normal distribution is going to be a histogram like this when you make the data. So you take a data set and you graph it. You'll get a graph like this where the graph will have a nice symmetric bell-shaped distribution. So symmetric, in your image, think that the two sides of the graph will be even. So like this one's not normal because you can see this side's all spread out. There's data here kind of all spread out. There's this side that kind of drops like a rock. So this is not a good normal distribution. A nice normal distribution is going to be what you think of like a bell curve. It's what we kind of typically think. Nice, very evenly spread out. That bell shape means kind of on the bottom edges when you're going out, it gets thinner and thinner and thinner, makes this nice flared bell shape. And that's going to be stuff we want to work with, but this one is definitely not normal distribution. So this first one we saw on that first page, this would be a form of normal distribution. You see how it's pretty even, spread out, and towards the end it kind of flares outwards. Makes a nice bell. If you put a chime in here and it bangs back and forth, it'd make a nice bell sound. This would be a bell distribution. And that'd be a normal distribution. So when statisticians are working with data sets, they like to work with data sets that look like this after you graph them. If they look like this when you graph them, it usually makes the math easier. Doing a lot of computations, calculations we're going to do later on. If we have this kind of data, we get to do it and it makes life easy. So that's what people look for. They look for normal distributions. The other thing people look for is outliers. Now, outliers is not something you want. This is actually something you don't want. An outlier is a data value that is either much larger or much smaller than the rest of your values. So it's going to be something that's just an outlier. It's going to be unusual. It's not what you expect. So it's a value that's much larger or much smaller than the rest. So you go out and you collect your data. You're doing family sizes. And you get that one family that's big, right? Lots of kids. In this case, it'd be your family of size 9. That would be an outlier in this case because there's no families with 8 kids, no families with 7 kids. The biggest other one we have is one family with 6 kids, but there's a gap here. So that makes this 9 an outlier. A lot of times when you're doing statistics, you're looking at experiments or drug tests, stuff like that. An outlier usually means that maybe the experiment was performed incorrectly, so it didn't come out similar to the rest. Something went wrong with the drug treatment. It's an anomaly. It's not what you want. Usually this is why when people do experiments, they take lab notes and stuff to make sure that they can watch out for and maybe determine if an outlier is actually a valid value, if it makes sense, if it's a real value. In this case, there really is a family with 9 kids, so that's a real value. But maybe if you're doing an experiment, you might look and say, oh, that's not real. We don't have to worry about that value. We don't have to worry about that outlier because we figured out that's that one time where I poured too much of the solution into the beaker and it didn't work. So then we can throw it out. But outliers are values we don't really like to see. They make the math harder. That's one of the reasons we try to avoid them. Okay, now one more thing. You can use your calculator to create these frequency distributions, this histogram from these frequency distributions. This is a chart. It's called a frequency distribution because it's given the frequencies for different values. Here, these are all family sizes again. So we can actually make a histogram, use a histogram from your calculator. Now to do this, you're going to take your calculator. I don't know if you can hear that, but I dropped my calculator, made a lot of noise. Okay, with my calculator, we're going to put in this chart into the calculator, and then we're going to make the histogram from it. To do that, we're going to use the stat option. We'll use this option a whole bunch this semester. It's one of our top favorite buttons, the stat button, which makes sense, right, in stats class. So what we'll do is we'll hit stat, and then you have options here. The first one is edit. You're going to do this a lot. This is where you go if you want to put data in your calculator. So if I have a table of data like this, I hit stat and edit, and it's going to put those in there. So that's my first thing. I hit stat, and then edit. And then I can type in these values. Now I have them typed in here ahead of time, right? But if you don't have them typed in there, you just arrow to where you want to type, and then type your numbers. So if I want to type the 1, I hit 1, and then enter, 2, and then enter, and it puts the data values down there. It might start with a short list. You might already have data in there. If you ever have data that you don't want, so maybe I type something over here that I don't want, you can go to the top of the list and hit clear and enter, and it will clear out a list. Be careful not to use the delete key because you can delete these lists. If you ever do delete a list, you can rename a list. So say I want this list 3 to be a different list. there are list buttons down here. You can see the blue buttons, L1, L2, L3, L4. If I want to rename this list L4, I just hit second and hit that L4 button. You can see it's L3, L4 and rename it. Now, I don't think it let me do it because I had a L4 in there. So let's say I deleted my L3. I need to bring it back. I hit second L3, and now it should let me hit enter, and now I've got an L3 in there. Oh, I lied. I was pretty sure that's the way I did that. Okay. Well, I'm lying. There is a way to bring the L list back, and maybe I'll have to look it up and remind myself how to do it. That's what I get for trying to do that on the fly. I shouldn't have done that. But if you do clear out the lists, you can always go back to your calculator's reset option, hit second in the memory down here. There's a nice reset button. So if you ever get your lists all messed up and just need to reset them all, you can just reset all your defaults, reset all your RAM. It'll just take your calculator back to the factory default. It won't mess anything up because your calculator's used to going back to the reset to the factory default. But that's something you can do. If you ever go back and mess up your list and you just want to restart the calculator fresh, that second mem option is a great way to do it. Okay, well, I got the data in here. Now you want to see how to get the chart. So you're going to hit second stat plot. So you see up here it says stat plot over that y equals. This is how we graph for statistics class. So these stat plots will show up. Now mine are all off right now, so we're going to go ahead and first turn the first one on. You can turn on more than one graph, but we usually need one at a time for this class. We're not advanced stats, so we won't probably need more than one. So I'm going to hit enter, and the very first option is on or off. I'm going to hit enter, and now it's on, so this graph will show up. The next thing, to scroll down, I'm going to pick which graph to see, because there's actually 6 different options for graphs. We'll use a few of these throughout the semester. First graph we want to use is the histogram. And it's a little series of bars. It's the third option in. So I'm going to scroll over that and hit enter. Your graphs might show up in 2 lines. If you scroll over, you can still get to the third one. And then it's going to have 2 lists. It's going to have the X list and the frequency list. So I'm going to use the X list. This is going to be our L1. That's going to be this set of family sizes. And then the frequency list for mine, it's going to be these frequencies we had right here. Now, if you had maybe a list of values without a frequency list, if maybe you just had like how many of there was of this stuff, maybe the 1 shows up 143 times, the 200 shows up 154 times, then you would just leave this as 1 because every option would count. But I want to use this frequency list, so I'm going to hit second and that 2 button because the 2 button will do my list 2. And that's how I get the list 2 in there. So I've got list 2. So I got list 1, list 2 because I have my list and my frequency list, and then I should be able to graph it. So when I'm all done, I hit enter through all that, I'm just going to hit graph. Now, you won't be able to see the graph very well right now because this graph right now is set for my algebra class to the standard zoom. So we want to zoom this for stats class. The way we zoom this for stats class is we hit the zoom button and scroll down to option 9. So option 9 is zoom for stats. You can either just hit option 9, you can just hit 9 on your calculator, hit enter, or you can scroll down to the 9 and hit enter. But either way, that'll make it zoomed in nicely for stats class. If you ever have data you want to graph and you want to see it, zoom 9 is the way to do it. You can also hit the trace key now. So now that we have this graph, you can hit the trace key, and it'll show you where you're at. So I'm at value 1, and I've got 143 for the number, value 2. And so it's not showing exactly 2 because it's showing the middle of the chart here. But value 2 is going to be the 154. Value 3 is 207. So it's actually giving me the heights for these. So over here you can see how this isn't quite matching up. 162 is supposed to be 4 and it's showing 3.9. We could see that I would round to 9. So that's something, round to 4, sorry, round to 4. So it does show you the heights though. If you ever do this where you don't know the frequencies, you can find them out by looking at the trace key for these different values. So there you go, that's your chart. You can hit second table and it will show you the values for the list. That's not going to be helpful, so let's ignore that. We'll just go back to graph. And again, trace key, the trace key does that. So we put the stats, we edit, we enter the data, we hit second stat plot, and then again we want the third graph. And our X list is going to be L1, And our frequency list was going to be L2. So we're going to put frequency as L2. So that's how we did that. Again, X list was L1, frequency list was L2. Put it all in there, hit graph, and that's how we get the chart for this. So, okay, move on. Okay, I already talked about how a little bit that the statisticians use the shape of a graph. They should look at the shape of the histogram, and that actually gives them information about the histogram. It tells them information that's important to know. One of the things they look for is the modality. So modality is just the number of peaks. High point for a set of data is not a large value, it's a large number of repeated values. So modality is marking off where you have a lot of the same result. So it might be a high value, it might be a low value, but it's something where you get it happen a lot. So like this first one is unimodal because it has one mode right there. Uni meaning singular, so there's only one. So this is unimodal, and this would be like something you might see if I think about like the income levels of employees at like a fast food restaurant, where you typically make close to minimum wage. A lot of people make just a little bit more because they've worked there for a little bit, maybe have compensation for having experience, or maybe like shift management, something like that, where you get a little bit better pay. And so you can have a lot of people close to the low end because fast food you don't typically make up to the higher end. But you have some people that do make more money, like the manager and the owner. And so this mode here is showing this peak where this is going to be the most common value. So the kind of the average, in a sense, is going to be this peak here. Most people are going to make around this amount of money. Some people make a little bit less, some people make way more. On the more side, it's more spread out. But this one is a mode because there's only one peak. You can also have bimodal, where you have two peaks. This will happen with a data set where there's two pretty common values. Usually this means that there's actually kind of some like two separate groups in your group that you're studying. So like maybe you're doing like a study on the heights of 7th graders, and you end up with these two different peaks. What could happen is that the higher peak, the peak that's further over, it's going to be the higher value, might be all those girls that have already hit their growth spurt, and so they've shot up, and that average height for those girls might be up here, whereas the average height for the 7th grade boys is still down here because they're still growing. And so you have two different peaks. You have the girls and the guys that have these two different averages because you kind of have two distinct groups. If you split up the two groups, you might not have that happen anymore. So that would be where you might see bimodal, where there's kind of two distinct groups within your set. If you have more than two, you might have multimodal. So multimodal, now we have more than just two peaks. I have three peaks. I think technically multimodal means just more than one. So you could use this for a sense, even for like this one. But most of the time, if you see something with two peaks, people are going to refer to it as bimodal because it has two exactly. And, bi, for bicycle, is an old Greek word for two, just like uni means one. So multi means many, so anything more than one is going to count. So more than one is going to be multimodal. But we usually aren't going to think multimodal until we get more than two peaks. And so in this case, we're going to have like three distinct sets of data kind of within our group. We could probably break this up three different ways. Okay, another thing you look at is symmetry. So symmetry is the shape of the graph. We already kind of mentioned symmetry when we talked about normal distribution, but symmetry is going to mean that the two pieces of the graph mirror each other. That's symmetric. So if you can draw a dotted line down the middle, draw some dotted line down the middle, and the two halves match, it's symmetric. So this is a symmetric bell-shaped curve. This right here is going to be the normal distribution. Again, we really like these normal distributions. When we see them, we're like, oh, sweet, the math is going to be easy now. Life is good. And these are the things we look for. You can have other kinds of data. You can have this where it's triangular. This is not as nice to work with, so we're going to kind of avoid these. But this is still symmetrical, right, because the two sides match. This one's called uniform because there's no peak here, so everything's just kind of level. And this one, of course, has a symmetry because the whole thing is the same height. So that's still going to be symmetrical. People call this uniform or rectangular. Again, we prefer to work the bell-shaped. That's the most common. It's kind of the easiest set to work with, easier than these other two sets. But these are all just ideas of being symmetrical. Versus like up here, this one would not be symmetrical. because the peak is on the one side and the right side is more spread out. Now, if you have a unimodal graph that is not symmetric, it's either going to be right skewed or left skewed. Now, I kind of put these backwards on purpose because I really want to point out something that I messed up when I was first learning stats, and you probably might get messed up here too, is that the skewness is not about the peak, it's about the spread. So if you look at the data here, you can see we have a peak up here, and then on the right side, it's more spread out. So this spread, the fact that this side is more spread out, that's what makes it skewed. Skewness is all about which side is all the spread out side. It's not about the peak, it's about the spread. So left skewed, again, left skewed is going to be the left side being spread out. So it's left skewed if the left side is spread out, and it's right skewed if the right side is spread out. So that's the big difference there versus right versus left skewed. It's where it's spread out. It's spread, not peak. So if it's unimodal and not symmetric, it only has one peak, it's unimodal, you look at the spread to find the skewness. So this is the hue. This is the skew. Okay, so again, a statistician looks at this. They just see this picture, and right off the bat, they see, oh, it's skewed on the right side, and there's a peak over here. Now I look at this data and think, oh, for some reason, the mode, the most common value, the thing that's going to happen most often is going to be on the lower end, and the right side is going to be really spread out. There's going to be values that are really big that happen. They don't happen very often. It's a low peak. It's low down here, but they still happen. Versus down here, it dies off really quick. So really low values are not very common. But once you hit the more common values right away. So the shape of these values, the shape of these distributions, tell a statistician a lot. We'll get more into that later on throughout the semester. Again, we'll be looking for those uniform graphs, the nice bell-shaped uniform graphs. Uniform, normal. I'm terrible. I always have a hard time not saying uniform when I mean normal. So I'm sorry. I'll probably do that in the future. I'll try and catch myself. A normal graph is what we look for. They're nice bell-shaped normal distributions. That's what we like to work with. Okay. So let's do this. Let's practice. Let's look at these graphs and see what we can look for. So again, we're going to look at the modality. So how many peaks does it have? We're going to look at whether or not it has symmetry. We're going to look at whether or not it's right or left skewed. So those are the things we'll look for. So like the first graph, we can see it is uniform. There's one nice peak here. So we're going to call it, not uniform, unimodal. So it's unimodal. There's only one peak. It doesn't look like it's skewed one side or the other. This is pretty evenly spread. You can kind of put a dotted line here and see that it mostly matches. You don't have to match it exactly because this is a set of data, so it's never going to line up perfectly, but we would definitely call this symmetric. As long as it's reasonably similar on both sides, it's fairly similar, we're going to call it symmetric. This next one, of course, has two peaks, right? This one and this one. You might be saying, but that peak's higher. Isn't that the only peak? They don't have to necessarily both be the same height. As long as you can kind of have a clear peak, we'll call that a peak. And so this one we definitely would say is bimodal. You have two kind of distinct peaks. The reason why one peak might be lower than the other is it might be a little more spread out, or maybe the two groups are different size. So maybe we had like the group of boys and girls that we did last time, but there's less boys than there are girls in the school. And so then one peak might be a little bit higher. This still kind of shows two distinct groups within the set. This one we'd say is probably not quite, or I guess this one, it's not unimodal, so we're not really going to talk about whether it's left skewed, right skewed, or symmetric. It doesn't really make so much sense because it's this bimodal shape. This one, we'd probably call this uniform. It doesn't look like it really has any good peak anywhere. It's kind of just about the same level the whole time, and so we'd probably call this uniform. You could argue that this was symmetric, because you say uniform, you can just draw that dotted line. So if you wanted to, we could definitely call that symmetric. But again, we usually worry mostly about symmetric when we're looking at unimodal sets. This one is definitely unimodal. It's just got that one peak here. And it's unimodal, but the left side is spread out. So this is left skewed. So again, we're looking at where the spread out is, not the peak, where the spread out is, and that tells us skewness. So this is left skewed. Here again, we probably have a bimodal. So we call that bimodal. and don't really have a lot to say about like left skewed, right skewed, symmetric. This one, again, one peak, so we'll say unimodal. And over here we can see that spread, so we'll call this one right skewed. Down here, this one, it's got two peaks. This is definitely bimodal. You could argue this one as symmetric. So you can see here, if you draw a dotted line right here, you could probably argue this is symmetric. Again, we don't really worry as much about symmetry with bimodal. This one's pretty clear that these two peaks match. So I would argue that one's symmetric. And again, we only really worry about skewness if it's a unimodal. It's really kind of hard to talk about skewness when there's two peaks. Last one, it's got 1, 2, 3 looking peaks, so we'd call that multimodal. So again, if it's going to have more than two, we're going to refer to that as multimodal. So we'll say that one's multimodal. So again, just the shape of the graph, just looking at the shape of the graph can give you information about the set. I can see there's probably 3 distinct groups here. I can see there's 2 split groups, and they're pretty evenly split up. One group, and it's the right skewed, so there's a peak over here on the left side, and it tells me information about the data set. Okay, now histograms are not the only chart you work with in statistics, so we're going to talk about some of the other charts. Like I said, histograms is probably the most important one. That's why we spent so much time on it. We'll see histograms come up throughout the semester. These other ones probably not quite so much, but we're just going to introduce them a little bit. First one here is called a dot plot. So a dot plot is a set of dots graphed over some kind of horizontal scale. So you see these dots down here, graphed over this chart. It's a lot like a histogram, but instead of using bars, we use dots. This is great because it kind of show information specifically like the number, how high the frequency is without a scale on the side. So you could just use the dots and see, okay, this one's 2 high, this one's 1 high, this one's 6 high. So you can get the heights just by counting. A lot of times this gets used as well when you might want to see like the group that's in the 30 range. So these are all between 30 and 32, but then by splitting the dots up like this, you can see where the 30s, the 31s, and the 32s are. So certain situations where you might use it, again, you only use this with quantitative data, just like a histogram, so this would be numerical data. Another graph we have is the scatter plot. So a scatter plot, we will see further on in the semester. This is when you have 2 different values that go with a set of data. So we have paired data kind of thing. So here they're looking at temperatures and the number of customers for an ice cream stand. So of course, the temperature goes up. You can kind of see this trend that it's kind of going up to the right. And a lot of times people use that in scatter plots. That's like quantitative data that has 2 different descriptors, in this case temperature and the number of customers, and then they'll graph it and see if they can find some kind of link between the two. And the link it looks like here is that probably as temperatures rise that we get more customers, which makes sense. Now, not all those links that we find like this are valid, so be careful about drawing conclusions based on data that looks like this. We'll talk about that later on in the semester, how that's a dangerous thing to do. But a lot of people use this. A lot of people make scatter plots and say, what's the connection between these two pieces of information? And then try and use that trend to make informed decisions. Another one we have is stem plots. So a stem plot, again, is another quantitative set of data. Stem plot is made up of a stem, which is the leftmost digit. So like at the number 15, it's going to be the 1, and the leaf. The leaf is going to be the rightmost digit. So in the number 15, it's going to be the 5. So in the middle, you put the stems. So we put the stems here in the middle. And then we put the leaves on either side. Now this graph is a combined stem plot. A lot of people will do combined stem plots where they actually have 2 sets of data on one stem plot. So like this side would be Wednesday's section's data. So like this number right here, 62. That's what this is, 62. The stems are the middle, the first numbers, and then the numbers over here are the second. So we have 62, 63, 69, 72, 76, 81, 81, 82, 83. And so it's just a way to list all the data in a chart that kind of shows some trends. Like I can look at this one and see that no one's in the 40s or 50s with this. Everything's 60s, 70s, 80s, 90s. So if this is like grades for classes, you can see that everybody in this class is getting 60 or above. No one's failing in this group. So that's kind of cool information about this one. Here we see people getting 49s, 51s. I know it feels backwards over here because this is the left value, that's the right value. So that's 49, 51, 56, 58. But here you can see there's like 4 people failing. There's a lot more D's in this class. not nearly as many 90 things, which would be A's in this class. So that's a stem plot. This is a combined stem plot. And again, a stem plot just shows the stem, which is the tens place, and then the leaves, which are going to be the ones place when you write your numbers. So that's a stem plot. Next thing we have is a time series. So time series is when you graph quantitative data at different points in time. So the data is based at points in time. So you might graph the temperature over a number of hours throughout the day, and then you can see the time vary throughout the day. That'd be a time series. On bar graph, we talked about bar graph already because the histogram looks like a bar graph, but a bar graph is actually used to represent qualitative data. So if you made a chart for your class that shows the number of people with blue eyes and green eyes and brown eyes, that would be a bar graph where you'd use the frequency still on the side, on the vertical, and that frequency would give you, the counts for how many people have blue eyes and green eyes and brown eyes. But then the bars aren't going to be smushed together, and they're not going to be going up in order because there's no way to order, eye color really. You can order alphabetically, but that's not a numerical order. So we don't have to put it like we did the histograms where we start with the smallest and go up. So bar graph is used for qualitative or label data, and you use spaced bars. And that's kind of one way you can tell the difference between a bar graph and a histogram, is a bar graph is going to have space between each bar because you're going to have these separate values. We're measuring all the different eye colors, but they're all separate eye colors. They're not clunched together like a histogram. Last one is a Pareto chart. This is something your book mentions. So a Pareto chart, it's just a bar graph where they arrange in descending order. So by frequency. So this is something where they look and say, okay, I've got the most blue and then the next most yellow, green and the next most brown, and they order that way. So they have a reason to order. They order by frequency, starting with the largest and then working their way down. This could be misleading if you're trying to create charts. People might misconstrue stuff as important because it's put on the left side because it's high. But if you're looking at a group and you want to discern what's most common first, this is helpful in that because in that things that the most common is going to show up first. So that's a Pareto chart, just a type of bar graph. Okay, last page. So your book also talks about in this section with the graphs that people will use graphs deceptively to mislead people, to misconstrue data. And so a couple of the big things you need to watch out for when you see charts and graphs. The first off is vertical scales should always start at 0. So what you'll see here is they have two different scales and they both start at different values. They have this chart that starts at 10% and this one starts at 0%. Well, they should start at 0. So this is actually the better graph because here you'll notice that there is definitely a difference between the Oxycontin test recipients and the placebo recipients. And that's the difference. But over here, this chart, you'll notice that the difference looks like this. And it looks huge. It makes this Oxycontin look like, oh man, it's so much better than the placebo group. There's such a huge difference. And it's because what they did is they cut off the bottom part of the graph. So if you take this bottom part and you blow it up so it looks like this, so you cut off the bottom part and you just look at the top part, then you can say, oh, that is huge, such a big difference, because you're not comparing it to the total test group. You're dropping off the bottom, part that, where they matched up. So you always want to start with 0. So this is misleading. I think I might have kind of said that backwards. So yeah, but this is what they chopped off to make this misleading graph. So this one is misleading. Again, it makes the difference look huge when it's only that much difference. So we always want to look and say, okay, why are they starting at 10 instead of 0? Something we always want to watch out for. The kind of differences are exaggerated if they just begin at some other point than 0. Another thing people do, so pictographs, when they use objects with area for one-dimensional amounts. So here you can see this is like a budget chart, and they're showing what part of the budget is spent on this and that and whatever. But this doesn't really work because what they're doing is they're taking a number like 28.7, which is just a length, an amount, it's a height or whatever, how much money, and they're turning it into an area. What this does is it exaggerates these numbers. It actually makes this 28.7 look huge compared to numbers like 5.9. 5.9 looks so small compared to this guy. That's such a big difference. But this one's only supposed to be like 4 times bigger than that. and this looks much smaller than a fourth of that. So it exaggerates differences. It makes things that should be not quite so different look more different than they are. So if you see a graph where they use like pictures to represent amounts, you really kind of want to be careful with that. Make your own graph that doesn't use pictures and see what it looks like then. Because again, pictures like this are misleading. So if graphs use pictures, do not make conclusions. Make your own graph and with the data and see what it looks like, because that can be very misleading. Okay, so that's our second section. We're just kind of getting into the idea of graphs, charts, histograms. From here on, we'll get started into some more statistical computations. We haven't really gotten to that yet, but we'll see that when we hit chapter 3. So chapter 2, again, you should be ready to read histograms, should be ready to discern information from those, make your own histogram, whether by hand or a chart. Again, my math lab won't really have, you'll be able to make charts and stuff, but you'll kind of probably have multiple choice options for in my math lab. It's probably not going to be drawing your own chart just like this, but this just kind of represents how we do that. You should be able to make a histogram with your calculator. It's a nice thing to be able to do. And you should be able to recognize some of these characteristics of charts, these histograms. You should know about modality, symmetry, skewness, and be able to identify those from graphs. So. And then again, these other charts, we're not going to see these as often. Some of these, like the scatter plot, we'll see further on, like towards Unit 3, or the last like test area thing we cover. But some of these we won't really see a whole lot this much. You see them in real life all the time. All these charts will show up in magazines, textbooks, that kind of stuff. That's why we went over them real quick. But you probably won't see them a lot throughout this semester. All right, so that's what we covered in Chapter 2, Section 2.2 and 2.3. That's the second homework assignment. Hopefully that helps you get ready for that, and you have a great time getting through that homework. As always, if you have questions when you're doing the homework, use the Ask My Instructor button, shoot me an email so I can answer your questions and help you out.